Today's topic is reflections in the axes. You can use April 21st for your notes. If your notes came a little bit disorganized, these are the first 3 pages of the packet, and these are the last 3 for the note packet. Let's start with some basic information. When we perform any type of transformation, and there are 4 of them, we typically graph in the coordinate plane. So anytime you have to graph a figure, we want to make sure we know which figure is the original figure that we started with. We typically call this the pre-image. In my picture on the right, the blue triangle is my pre-image. Every transformation that the figure does undergo produces an image, which is a copy of the original figure. We want to know which one is the copy, so we're going to mark that one with a special notation called prime notation. So the red figure is the copy, and you can see it's P with this little tick mark that is read as P prime. And every vertex has the prime notation. So blue is the pre-image, red is the image. We want to make sure we label every single point. That's an important aspect in identifying the pre-image and the image. When you transform any point, line, or figure, it may appear that some points don't move. We call these invariant points or fixed points. They are undergoing the same transformation, but their pre-image and image location just happens to be in the same spot. This is our formal definition of a transformation. Basically, it's a one-to-one correspondence between points. So for every point on the pre-image, you should also find another point for the image somewhere else in the coordinate plane. Remember, you can stop the video at any time to catch up on your notes. The word isometry represents what we call a rigid motion of the plane. If you take your figure and you transform it, we have reflections, rotations, dilations, and translations. It doesn't matter which type, many of those simply move the figure to a new location. So the distance between the points on the pre-image remains unchanged. So if you had a square that you moved, if it had side lengths of 4, depending on which type of transformation, the side lengths will still have 4. So the pre-image and the image are identical. You're producing congruent figures. If you're performing a direct isometry, you're also preserving orientation or order. That means that the letters and the figure will all be going in the same direction. It doesn't matter if it's clockwise or counterclockwise, but it will look like an identical picture. So in my image here, the blue triangle is your pre-image. All we did was slide it over to create the red triangle. You can see that A, B, and C are in the same order, and the triangle is facing the same direction. Some transformations do not preserve orientation, so this would be called a non-direct or opposite isometry. You still have a congruent image, it's just that it's sitting in the opposite direction, and the letters have all been reversed. Now we'll actually get into some reflections. When you have a reflection, you're creating a mirror image, and it can be of just a point, it could be a segment, it can be a line, or it can be a figure. We are taking our pre-image and basically flipping it over a line of symmetry. So sometimes they'll nickname a reflection a flip. We can see in these images, in the tree, the line of symmetry would go right through the center in a horizontal manner. So we're creating a reflection in the water. With the swans, we have 2 reflections. They're sitting in the water, so there's a horizontal line of reflection to create the image. But if we're not very picky about the size of the swans, we could go vertical and the swans would be an image of each other. So there's two lines of reflection there, or two lines of symmetry. Same with the hot air balloons. There's a horizontal line of symmetry at the water line, and we're creating a mirror image in the water. The reflections we're going to look at today involve using our X and our Y axes. So if they want you to reflect in the X axis, they're going to use a lowercase r as an abbreviation, and in subscript, they're going to put X axis. We use a lot of notation to simplify the process. So if you were to read this, it says reflect in the X axis, triangle ABC. Triangle ABC is your pre-image, and it will equal or create triangle A prime, B prime, C prime, which is the image. Let's look at this diagram to see if we can figure out what's happening. Point C was located at 4, 2. I know that this is the original figure because there's no prime notation. When it moved to its new home, C prime is at 4, -2. Let's see if that's occurring in A. A was located at -2, 1. A prime is now located at -2, -1. So hopefully you're seeing the pattern. It appears as though the X coordinate will remain the same and the Y coordinate will become its opposite. So this is our generic rule. We're going to take any point P located in the coordinate plane, and generically it has the coordinates X, Y. The arrow says maps itself, and we always draw the arrow. It will become P prime, and now it's located at X, -Y. So X stays the same, the Y becomes its opposite. So this is a rule that you can memorize going over the X-axis. Once we get through much of this unit, there will be probably 10 rules. So sometimes people like to count. Counting is very simple. If we identify the X-axis, this is our line of symmetry or our line of reflection. My triangle on the top has to be folded over so that it ends up underneath. If you look at the location of A, to go from A to the line of reflection, we've got one block here. Its new home will also be one block in the opposite direction. So there's A prime. So we're counting. We can do the same with C and B. C is 1, 2 blocks from the line of reflection. So we're going to travel 1, 2 away, and there's its new location. So counting is a good strategy, especially once we have multiple rules. Let's try an example. Normally they give you ordered pairs, so they're giving us A, B, and C. We're going to graph that in our coordinate grid. So these are the locations. This is A, this is B, and C. The rule says reflect the triangle in the X-axis to create its image. It also says list the points. Whenever you do a transformation, we rewrite the ordered pairs and their names somewhere on the paper. So you can use your white space, but you want to write down the location of A, B, and C. Let's apply the rule. We said the rule states that the value of X will remain the same. So to go to A prime, it's going to map to A prime. X is still 1, but Y was -2 and now it's positive. So we'll do that with B prime. X stays the same, Y changes, and C prime. X stays the same, Y changes. Now that I know the locations of the image, I can go ahead and plot those in my coordinate grid. There's the triangle that is the image. Notice it's exactly the same size. Distance between points is unchanged. So this is now A prime, B prime, and C prime. So we've created an exact copy. The line of reflection X is where we would fold the paper, and the blue and the red triangles would line up in exactly the same spots. Let's try example 2. We're going to plot triangle ABC. Two of the ordered pairs are the same, one's changed. All right, so we've got A, B, and C. What you'll notice is we're reflecting in the x-axis. This original figure is actually laying across the x-axis. So that's going to show some kind of special feature after we've done our reflection. So we're going to go over the x-axis. This time we're going to count. So if B is 1 unit above the line of reflection, B prime should be located 1 unit away. So this will be B prime. C, it's 4 units under the line of reflection. We're going to count 1, 2, 3, 4. And this will be the location of C prime. And A, up 2, and then 2 more. This is the location of A prime. My drawing isn't very good. Let me bring up. There we go. So the purple figure was the original. The red is the image. Notice if the original lies across the x-axis or the line of reflection, so will your image, and the figures themselves overlap. You can either extract your ordered pairs right from the diagram, or you can just simply apply the rule, and we know that x stays the same and y will change. So there's our ordered pairs. Please make sure you label all your points on your coordinate grid. Let's look at a reflection in the y-axis. If it helps, you can always circle or highlight the line of reflection. But let's see what's happening here. The figure on the right is my pre-image because there's no prime notation. We have A located at 2, 2. A prime is now negative 2, 2. B was at 4, 4. Now it's at negative 4, 4. Can you identify the pattern? So the abbreviation is very similar. Lowercase r for reflection, and in subscript, it will state the y-axis. And again, we want to make sure we can read the notation. So we're going to reflect triangle ABC in the y-axis to create its image, triangle A prime, B prime, C prime. If you noticed as we were comparing the pre-image and the image, it appears that the x-coordinate is now changing and y stays the same. So where it says rule, we're going to take our generic point P, located somewhere in the coordinate plane. It will map itself to P prime. X becomes its opposite, y stays the same. Now we have 2 rules. And again, if you have trouble memorizing the rules, we can count. So A is 1, 2 units from the line of reflection. We would count away 1, 2. And now we found its new location. Let's try example number 3. We're going to plot triangle DEF. And there it is. We are going to reflect in the y-axis, so we want to go over this line of symmetry. So again, the figure is lying across. If we apply the rule to our ordered pairs down below, X will change, Y will stay the same. We're going to do that with D, E, and F. One other thing that I forgot to mention in some of the others, above the arrows that represent the map, we need to put the abbreviation. This is reflect, and we want to put Y axis. And we should have done that with the other examples. We should write the rule above the arrows that tells the reader what we're doing. These are the locations of our prime image, so let me graph that, and they do overlap. And again, all the points in the coordinate grid should be labeled. Mine don't look so good trying to use the PowerPoint marker. For our last example, we're taking a quadrilateral WXYZ. It says to reflect it in the y-axis to create its image. They did not provide a grid. If you know the rule, you can simply just draw the mapping. So we're going to move W. X will change, Y stays the same. We'll do that with X and Y and Z. And the other thing we need up here is our rule. So this is a reflection in the y-axis. So when we reflect in the x and the y-axis, let's look at the properties. Invariant properties are things that do not change. So the size of the figure is preserved. That is a word that they use quite often. They're just saying that it stayed the same. The shape of the figure is also preserved. When we reflect it, it's still the exact same shape. Because we're creating congruent figures, all the angle measures are also preserved. Distance between points is preserved. That means that a reflection is an isometry. Any sides that were parallel on the pre-image will also continue to be parallel on the image, as well as any points that were collinear, they will continue to be collinear on your image. So when you perform a reflection, the original figure and its image are going to be congruent. So a reflection is classified as an isometry, which is a rigid motion. Basically, I grabbed it and I flipped it over, but otherwise it's the same. Because it's an isometry though, and it's facing a different direction, this is called an opposite isometry or a non-direct. So the shape is the same, but the letters will be in a different order. This is homework number 115. You'll see it says reflections in the axes. There were 3 pages to this assignment. Make sure when you get to this 3rd page that you write the original ordered pairs and then do a complete mapping with the rule above. Same thing with the grids. Write down the original ordered pairs and then do the full mapping so that you get all of your credit. If you have any questions going through this assignment, please contact me somehow so we can clear it up, and have a great day.